Thank you for joining us for the Anzo Product Tour. Today we'll be focusing on genomics data.
Thank you, Barbara. Here in front of you, you can see the landing page for Anzo. On the left-hand side, you'll see the 4 primary steps of our process. That's onboarding, modeling, blending, and accessing your data. We're going to go through each of those steps, show how they work, show what it takes to get through them. But I think for this particular demonstration, it will really help us to start in the model section, get an idea of the context of what kind of concepts and data we're looking at, and then work our way back to the onboarding stage to see how we got there, see how that model was made. Now, this is Anzo's model viewer. You can see that we have a collection of a couple different models here that have been linked. We'll get into this more when we talk about onboarding, but the really useful thing to note here is that each of these individual submodels, each represented by a different color, was created by Anzo by analyzing the schema of the data source that was onboarded. So if we look, if I zoom in here a little bit at this particular data source for clinical cases, you can see that there were clinical case information, exposures, diagnoses information and treatments, demographic and family histories for that particular data source, and those were broken out into separate classes and linked using properties in this model, all done by Anzo, all done automatically. The only steps that I took in the process to unify these were to create these couple of linkages here in between, where I noticed that a biosample has a concept of a clinical case ID, shown here, and a clinical case has the idea of a case ID, shown here. So I was able to create this has biosample link between clinical cases and biosamples, where a clinical case is linked to a biosample if they share a common case ID. Just to get a concept of more of the data that we have here, you can see we have our clinical case information, a link out to a drug catalog, so what drugs were used in particular clinical cases, a link out to the biopsy information, and then a link to this unifying concept of simple somatic mutation occurrence, which makes a mention of a particular clinical case and any simple somatic mutations that were observed on that clinical case. That will then take us out to our mutations graph, and that mutations graph will then allow us to connect out to our gene catalog. So how did we get here? Let's work our way back to the onboarding stage. You can see we have 2 options here, structured and unstructured data. In this particular demonstration, we'll be looking primarily at the structured data. And here are the data sources that inform the model that I showed you previously. We have 5 JSON data sources, our biospecimen, clinical case, gene, that unifying oncogrid concept, and the mutations information. And we have a collection of CSVs that have the drug information or drug occurrences in them. Of note here, I'm using a subset of our mutations data just for the simplicity of this demonstration. Specifically, that subset is those mutations associated with skin cancers or observed in clinical cases that were treated for skin cancers. If we want to look at any of these data sources in a bit more detail, we can look at the schemas tab. Let's look at clinical cases, for example. This will start to pull back some metadata associated with our data sources. We can see the semantic typings for each field, as well as any primary and foreign keys that were created. And again, this was done automatically by Anzo. So it was able to parse the data in the fields and then determine the semantic typing appropriate for that field off of the data within it. It was also able to analyze, in this case, the structure of the JSON to inform these primary and foreign key relationships. However, if we were onboarding a database, something like a SQL database, and you had existing primary foreign keys within your database schema, we would be able to interrogate that database and then extract those primary foreign key relationships and use them to inform the graph in the same way you're going to see that we used the structure of the JSON to inform the creation of the graph. If, however, you onboard a data source and it does not have one of those primary and foreign keys that you would like it to have, or you just didn't have them in your database to begin with, you can go ahead and create some here. You can create an additional primary foreign key, and to create or dictate that something is a primary key, it's as easy as coming into this edit field and calling it a primary key. So once you're happy with the metadata associated with your data source, you can actually come over to this mapping section. And this is where we're going to create the unification between your model, your ontological model, and the data source that's coming in. Now, in the case of automatically onboarding your data, like I did for these, this mapping was created automatically along with the model, and the pipelines, the ETL jobs that will perform that transformation of your data into a graph representation that was also created automatically by Anzo as well. So this mapping is a fairly straightforward concept since it was auto-generated. We can see that within our clinical cases JSON file, there was a concept called exposures. And within that concept called exposures, there was a key value pair called alcohol days per week. And that alcohol days per week is now being mapped from the source to a property within our target ontology called alcohol days per week, pulled directly from the data source itself. So all of this was generated automatically by Anzo. However, if there's a scenario where you'd like to create your model by hand and then you'd like to map your data to that model, we offer a suite of tooling around that will allow you to create these mappings to link to a model you have. Or if you'd like to use the auto ingest functionality to create everything you see in front of you here, and then tweak and edit that auto-generated mapping or model or pipeline, you're more than welcome to do that as well. And in fact, that's one of my favorite ways to use the platform because it really takes care of a lot of that upfront legwork, that mapping, that modeling legwork that you really don't want to do by hand. Anzo can do for you, and all you're responsible for after that is to apply those minor alterations that really make that data model conform to your specific enterprise use case. The last thing I want to say about mappings here is that this is a point of potential transformation of your data within the Anzo process. We can see that these are simple one-to-one mappings, alcohol days per week being mapped to the property alcohol days per week. But what I can do with the tooling we have available is I can add in potentially some transformative functions to my data as it goes through the ETL transformation process. So I can say there was some sensitive information, say there were first and last names in my data source that maybe I wanted to have them represented in the final data, but I wanted to make sure that the security of my patients was maintained. So I could mask that first and last name by applying a function at this stage so that when the ETL job is done, when that pipeline is run and a RDF data set is created, you are able to then see the data in its transformed state from that point going forward. Now that we've talked about mappings, we've talked about the models, we've talked about your data sources and the metadata you can see from them and what you can edit there. If you're satisfied with your mappings and your model and your data sources, we can move on to the pipelines themselves. Now this is what actually performs the RDF graph representation transformation of your data. It will take your data sources into account, your mappings and your model, and go ahead and run a Spark job to create an RDF data set, what we'll refer to as an RDF data set from this point going forward. You can see that Anzo comes prepackaged with a local Spark engine built in, and it's fairly robust. You can use it for a number of ETL capabilities, but if you're looking to ETL data on the order of hundreds of columns wide or potentially millions of rows deep, you might want to outsource that computational load to something like a Spark cluster that you could spin up, and then that would shoot through that ETL process significantly more quickly. But Anzo does come out of the box already ready to go with a local Spark engine built in that'll service a lot of your needs. Let's take a look at one of those Spark jobs in detail here. It's a fairly simple operation, but it's useful to see. We can see our original data source here, our JSON file, complete clinical data, and it's taking into account our mappings and our model, and the Spark job will then output the RDF graph representation of your data here, which again we'll refer to as an RDF data set. I want to briefly touch on the model one more time just to kind of show you the model editing capabilities that would go into this process. We have our classes within our models, and we have our properties. You are able to add a property to a class or a subclass to a class very easily, just one of these options here. Or you can add a class to a model, add a property, annotations, data range. And for any of these elements here, we have this Edit tab where you can change the label, the URI, add a description. In the case of properties, you can add domain and range and cardinality restrictions. In the case of classes, you can attach properties to those classes or manipulate any resource templates, so how your URIs are going to be generated off of that class as you onboard your data. All of that's modifiable right here within the model viewer. And that's in fact how I went about linking these data sources. I created a property between my biopsy, this has biosample property. All I did was I came into here, I said add property, and I called it has biosample. And then within it, I was able to define that the domain of that property is clinical case and the range is biosample, creating the view that you see here. So that covers the majority of a high-level look at our onboarding process, how you would model your data, how you can use Anzo's auto onboarding capabilities to create a model for you, create mappings and pipelines, and how you can edit and tweak those mappings, models, and pipelines to your specific use cases. I'll transition over to the blend stage of our process here, where we have that collection of RDF data sets that I mentioned earlier. So every single pipeline run will create an RDF data set in this spot here. This is a catalog. It's fully searchable, filterable, however you want to access your data sets here. And by default, you have a specific data source. We'll go through an ETL job, and that data source will be one-to-one with a data set. However, that's not necessary. If you're wanting, for example, to create multiple data sources converging on a singular data set to kind of consolidate your data, you're welcome to do that. And likewise, you can take a singular data source and subset it into multiple data sets if that's what's most useful for your particular use case. However, in this example, we're going to be going with the default setting of each data source gets a data set. Now, if we want to collect those data sets into an analytics-ready data collection, we call that a graph mart, and I have one pre-prepared for you here. All a graph mart is a subset of your data sets that will be loaded into memory for the purposes of answering or asking a set of particular analytics use case questions. And we can see the specific data sets that I pulled into this one here. We have our biospecimen data, clinical cases, gene catalog, that OncoGrid unifying concept, mutations, and our drug information. Here we have our data layers, and you can think of this, the analogy is to look at something like Photoshop, where you have multiple layers of images you can stack on top of one another to create one comprehensive image. And by default, each data layer is simply the load step of a particular data set. You can see here the skin mutations data layer contains the load step of the skin mutations data set. And we then stack all of those data sets together into a singular graph database, which you can then query and ask questions of. But there's so much more capability here that you have access to. If I want to add steps to a particular data layer, I can add a query step, perhaps an insert query where I want to add some relationships or insert some new triples in accordance with a pattern, or maybe a delete query that I want to remove and filter out certain subsets of my data just for this particular use case or question. We can add an inferencing step and validation steps for QA. We can create a view, and this is a rectangularization of your data that's persisted in memory, which you can then pipe out to any other tool. Or you can create a templated step. So in the event where someone creates a step that you find very useful and you want to share throughout your enterprise, you can create a template where another user can then use that template, fill out a form, and will apply someone else's step to their particular use case based on what they put in that form. I want to touch on data on demand here just briefly. This is how you would expose your data to something like your Spotfire, your Tableau, your SAS via an OData, ODBC, or JDBC endpoint. We can see that I've got one created here that I made specifically for Spotfire. However, you can access this from any BI tool, something like I said, Tableau or Spotfire, and you will be able to view a rectangularization of your data that would be interpretable by those BI tools. Now, Anzo does come prepackaged with our high-res analytics BI tool, which operates directly on top of the graph, which gives you enormous capability to analyze trends and relationships and walk the graph, and we'll show you that in just a moment. However, we do realize that a number of enterprises do have their preferred analytics tools of choice, and we want to make sure that you can access your data in the way that's most useful and comfortable for you. And that's what you would do with this. So we've talked about the what of the graph mart and the how it's made, but I really want to dive into how is this all happening really? What's the infrastructure behind it? So Anzo comes with the Anzo Graph Database, which is a massively parallel processing in-memory graph database. So what does that mean ultimately? It means excellent performance. It means that we're able to scale up to the demand of an enterprise as far as data scale goes size-wise. We've benchmarked up to 1 trillion triples and seen performance here. You can then query that at speed and with efficiency because of the in-memory nature and the massively parallel processing nature of our Anzo Graph database. So now that we've shown you how you can build this analytics-ready data set and pull it up into memory, let's go ahead and show you what you can do with it. What are the capabilities? I've prepared a few dashboards here that answer some very specific use case questions for the world of cancer analytics. But let's first take a look at the high-res platform in general. On the left, you can see some standard BI functionality. I've got some filters here. I can filter on primary diagnosis for my clinical cases, tissue or organ of origin, the vital status of my clinical case, etc., general demographic information. But really the benefit of this is that I can start to traverse the various data sources that I have loaded into my graph mart in a very seamless and smooth way. For example, let's look at this first table here at the top. I have some information from my clinical cases database here. I've got some demographic information, the gender, the age of diagnosis, their current vital status, whether they're alive, dead, or not reported, the tissue or organ of origin for their specific cancer, and the primary diagnosis as well. But if I go ahead and drill down into one of these examples here, for example, this particular male of age 68 with a prostate gland cancer, I can then access the biospecimens data based on how I've configured this particular table. I can view that this particular individual has 3 different biopsies that were taken, and we have some information regarding 2 of them. It's been 554 days since the collection of the first 2, and they each have their initial weights associated to them. And I can actually click on this link here, and that will take me back to the GDC portal, and I'll be able to view the images associated to each of those biopsies. We can see those here. Again, 3 biopsies taken, which it mirrors what we see in high res, according to our data. So we're showing you this representation here in tabular form, and it's very clean and elegant, but let's talk about how easy it is to get to this point. How do I traverse the graph using Anzo's UI? If I go to the designer for this table here, I'm able to add a column. And if I want to pull back some information that's not on this biosample data source, all I have to do is open up our UI and walk the graph. Let's say I want to pull back some diagnoses information and pull back the primary diagnosis for this particular patient. Well, I come in here, I'm now on that diagnoses class, analogous to a table in a traditional SQL graph database. And let me look for the primary diagnosis here. Primary diagnosis, I add that to my table. And we're now pulling back information from multiple data sources. I have biopsy information in this column. I have clinical case information in this column. And we're able to create this unified picture and navigate our data very cleanly. Now, each of those clicks was issuing a Sparkle query against your graph database under the hood, which you can actually view if you really want to here in the Help tab. But important to note is that I didn't need to have any mastery of Sparkle or graph databases or querying languages of any kind to create this view that you see in front of you. All I did was simply open the designer, add a column, and walk to the property that I want. Now let's take a look at some very specific analytics use case questions that we have prepared to showcase what you can do with this data in a graph structure. The first question we were asked was, for a given primary diagnosis, which drugs are used, with what frequency, and more importantly, with what outcome? So I have this first view here, and we look to answer that question with this particular dashboard. So for a given primary diagnosis, we can see a primary diagnosis filter here on the left. And let me go ahead and select the squamous cell carcinoma, and you'll see the screen update to reflect the data only relevant to squamous cell carcinomas. You can see that our table here has updated. Now we only see those drugs, and we only see the number of clinical cases that have used that drug relevant to squamous cell carcinomas, as well as this pie chart here at the bottom showcasing the cancer sites updating as well. Now for a particular drug, I can start to see here that this crisplotin has 110 clinical cases on record having used that drug, specifically treating squamous cell carcinomas, and a fatality rate of 38%. If I drill down even deeper here, I can start to look at the particular clinical cases which use that drug, what other drugs were taken, in this case Gemzar for this particular clinical case, and what dosages were associated to each of those drugs. And of course, the all-important vital status to answer the question that we were asked. And I can do this with any of the drugs that are relevant to this particular use case. We'll see that update here in real time. And again, the table down here, or the pie chart rather, updating in real time as well. The second question we were asked was, for each drug, show what genes are correlated and trend on the number of cases with that gene mutated. So I have the second question dashboard here. Once again, we have some filters on the left-hand side, and I want to drill down into a particular drug and look at what clinical cases do I have on file with both drug and mutation information. So here we have a table showcasing the drug information and how many clinical cases we have that have a drug information record as well as a mutation information record on file. For this carboplatin, we have 9 clinical cases on record that have both of those data sets. So let's go ahead and look at that in more detail. And you'll see the grid on the bottom, or the table on the bottom, updating to show it. Here we have, now that we're looking at carboplatin, we have this TTN gene is really rising to the surface with 4 clinical cases showcasing mutations on that gene. And we can start to view some information regarding the 9 clinical cases that are relevant to this particular drug as well. Here we have the tissue type for each clinical case, the number of mutations observed, and the primary diagnosis for that individual. And we can do this for any of the drugs that we're being asked about. The question asked about the number of clinical cases, but it was also interesting to look at the number of mutations occurring on each gene, so I prepared this table as well. And here again we see this TTN rising to the surface, the most mutations on record. However, interestingly enough, the most clinical cases on record belongs to this gene, but with this sample size it's fairly limited. So the final question we were asked was, for each tissue type or primary diagnosis, which genes are mutated most frequently? So here we have a filter on our tissue type, skin. If you remember, we have a mutation subset based on skin cancers, so this is going to be where we get the most accurate information. But I want to look even more closely regarding this question for each primary diagnosis. So let's drill down to the spindle cell melanoma and really look at information regarding the spindle cell melanoma. We can see a concentration of mutations on this chromosome 2 very prominently sticking out, and we can see the clinical cases that are relevant to the specific filters that we've applied. So we have these 2 clinical cases with 85 and 91 mutations observed, and we can drill down to one of them and start to see some more information about those mutations in general. We have mutations SSM ID, we have the type of mutation, so it's a single base substitution, the VEP impact, polyphen impact, SIFT impact, and the specific genomic DNA change that occurred in that mutation. If I wanted to drill down even deeper, I can say let's limit this down to just those mutations occurring on chromosome 2, and I can go ahead and apply that as well, pulling back even more information about the genes that we're looking at. What genes were mutated on chromosome 2, the specific gene IDs, gene names, and gene symbols, and how many mutations were observed. In this case, we see, once again, this TTN coming to the top with 17 mutations observed. Now the question asks something more general. I've shown you a very narrowed down use case, so let's actually look at, in general, how many mutations occurred on a specific gene for our specific diagnosis. And again, we see TTN rising to the surface here, followed closely by MUC16. So you can see how easy it is to ask these questions of your graph database and immediately receive answers by quickly navigating the graph to create these visualizations. And just to show you and really drive home what that means, that last visualization that we did, we were able to filter our clinical cases based on a field from our drug data source, based on the number of simple somatic mutations occurring, which we then pulled back more metadata associated to our mutations, and walked the graph over to our gene catalog and pulled back information from our gene catalog. We've leveraged every single one of our data sources in that one visualization, and it was incredibly easy to walk the graph and determine those relationships using our UI with no requirement of knowing any kind of SQL or Sparkle or graph database querying languages of any kind. So if you were trying to do that in a traditional relational tabular database, the SQL joins would be astronomical to create that across all of these various data sources, and you would have to rewrite those joins in every single query that you're issuing. The beauty of graph and semantics is that you do that joining and that harmonization up front, and that is then persisted so you can get straight to asking your questions, and it's flexible. You can ask any question at any time and receive your answer because of that upfront joining and harmonization that we did in the onboarding and modeling process. The flexibility is unparalleled in relationship to your traditional tabular databases. I want to end by navigating to this provenance viewer here and showing the journey that we went through for all of our data. So while this is loading, what it's doing is it's actually querying the underlying graph metadata catalog that we hold here within Anzo. And if you caught what that means, we don't just use graph and semantics as a way for you to navigate your own data. We believe it and we live it within our products. We capture every action as far as onboarding, modeling, blending, and accessing as a entry in our own internal graph database that captures your metadata catalog. So if we see here, we can trace back all the way to our data sources, our original data sources, and we can look at some of the metadata that we viewed earlier in the UI. What are the specific fields within that data source? We can then follow that to our mappings and see that each field is mapped to a property within our model. And if you applied any transformations in the mappings, those would show up here as well, so they have that traceability and visibility. That navigates through all the way from the model to the creation of your graph mart as a collection of your data sets, and all the way through the visualizations and other usages of your data from that graph mart. Now, this is just a general view of that metadata catalog that we have pre-made for you within the Anzo platform here in the provenance viewer, but because that underlying graph catalog is graph, you can turn Anzo back on itself and analyze the metadata catalog as if you were analyzing your own data as well. That means high-res analytics, that means your Tableau, Spotfire, or SAS, and you can also export this metadata catalog to any enterprise-wide metadata provenance tool of choice, and then you can have an end-to-end lineage across the entirety of your enterprise data from the outside of Anzo to the internal workings of Anzo's catalog, and then whatever happens after that as well. It can be seamlessly integrated to your existing provenance. At this point, I want to thank you for watching and turn things over to Barbara for a conclusion.
Thank you, Tim. Thank you very much for that. And thank you for joining us. If you found this interesting and would like to learn more, please reach out to your Cambridge Semantics account team or contact us at sales@cambridgesemantics.com. Thanks.